Hi, today we're going to talk about limits. First up, the definition. When we write out this notation here, this is read as the limit of f of x as x approaches a is equal to L. And what this means is we can make the value of the function f as close as we want to get it to L by taking x to be sufficiently close to this number a. And what we do is we use this to answer questions like what happens to the function value y when x gets really close to some pre-chosen value. So to start with, let's just look at an example with a graph. I'm going to go to Desmos and I'm going to graph this function, x squared plus x minus 30 over x minus 5. If I put that in here, I'm going to put in y equals x squared plus x minus 30, all of that over x minus 5. And we're wondering what happens to this when x gets really close to 5. Now, if we look at this graph, it looks like a line. But one thing you might notice is if we just plugged in the 5, we'd wind up getting 0 for the denominator. So this function's not defined at 5. It turns out we'd also get 0 in the numerator. So plugging 5 in would give us something undefined. So we can see that if we zoom in here. Let's look at this point. The x-coordinate is 5 here, and if we come up here and get right on 5, notice it says it's undefined. But if we zoom in and we look at these points, as our x value gets closer and closer to 5, our y value is getting closer to 11. And same thing if we approach from above. As we get x close to 5, y is approaching 11. So by looking at this graph, we would say that this function, the limit of this as x goes to 5 is 11. It's important to remember limits are concerned with what happens when x gets near 5, or whatever our number is. It doesn't really care what happens when x is equal to 5. Now this same graph, let's talk about one more limit. The limit as x goes to, let's say, 0 of this graph if we look at that, if we approach 0, if we approach this point here, which has an x-coordinate of 0, the closer we get, the y value starts to approach 6. And same thing from above. Now, in that case, the function's actually defined there. Over here at 5, function's not defined. And it doesn't really matter as far as the limit goes. The limit doesn't care if it's defined or not. It's just what happens when we get close. All right, so let's look at some one-sided limits and two-sided limits. When we did the limit before, we approached from both sides of 5 and then both sides of 0. If you only approach from one side or the other, you call it a one-sided limit. And the little notation here, this says the limit as the limit of f of x as x approaches a from the left. Sometimes I think of this as from the minus side. And same thing over here for approaching from the right, from the plus side. That's what the little superscripted minus and plus here mean. So let's look at an example. Here is a crazy looking function, and we've got a bunch of limits written down here. So this first one says find the limit as x goes to 1 from the negative side. So one way you can do this is you come over here to x equals 1, and you can draw a line, like a vertical line through there if you want to. Think of that as a wall. And now we're supposed to approach 1 from the left. So I go over here to 1, somewhere on this line. And since I'm approaching from the left, I move very slightly off to the left. So I move over here and I come down to my function. And now I approach this function from that side, and I look at what is the y value of the point that I'm approaching. And the y value of this point is 4. Similarly, if I look at the limit as x approaches 1 from the positive side, from the right, I go to my vertical line here, I move slightly to the right, go to the function, and then I ride along the function. You can think of it like a little ant walking on the function. As he gets closer and closer to the wall here, what's his y coordinate approaching? In this case, it's 2. All right. And over here, this is the two-sided limit. And I've got this written below, but I'll go ahead and say it now. If you have the two-sided limit, if these two things don't match up, we say that the two-sided limit does not exist. That's what D and E means. It's because if they tell you what happens when x approaches 1, but they don't tell you which side, then there's a different answer depending on whether you approach from the left or right. So we just have to say this limit doesn't exist. Now let's look at 3. I'm going to do this one in green. As x approaches 3 from the left, right, and overall, let's see what happens. So I'm going to come over here to 3, x equals 3, and draw in my vertical line or wall. And again, we're going to approach the wall from either side. If we approach from the left, we're coming down to this point, which has a y coordinate of 1. Now, sometimes people say, how do I know what to get on when I'm approaching? How do I know whether to go to this part of the function or this part? Well, you go to the part that's closest to, in this case, x equals 3. You go to this wall, and you just barely move off to the left or right. For this one, we're going to the left. And we approach down here, and as we get close to the wall, our y value approaches 1. Now to approach from the right, we do the same thing from over here. And we're approaching 1 again. And since both of those match up, our overall or two-sided limit is also 1. Now, so far on this example, we've looked at the two sort of interesting points, the places where the function has a jump in it or a break. But we can look at limits, one-sided or two-sided, at any place on the function. And I'm going to do that here. As x goes to 0 from the left, well, I come over here to 0, move slightly to the left, and when I come down here and I approach 0, I'm approaching this point here, which has the coordinate of 3. All right, if I approach -1, let's see, -1 is here. And this is a two-sided limit, but it looks like in both cases we are approaching the same number because there's not a jump there. So from this side we're approaching this point, and from this side we're approaching the same point. So I'm going to have to eyeball this. It looks like that might be maybe 2.4, roughly. And this last one, if we approach 4 from the right, over here we come to 4. Let's see, we go 1, 2, 3, 4. If we approach this from the right, we're going up towards 0. So, you know, on these last three examples, the direction really didn't factor into it, but it doesn't really change anything about it. So, anyway, that's a big example with a lot of limits. This next example is very similar to that. You might want to pause the video and you might want to pause the video and work these out for yourself and then unpause and check them. All right, let's look at this. X is approaching -2 from the left. So that's -2 approaching from the left. It's going to be -2. Approaching -2 from the right, the answer is 1. And the overall limit is going to be D and E because they don't match. Now approaching +2, let's see, 1, 2. Okay, from this side we're going up to positive infinity, and from this side we're going down to negative infinity. So this is also a D and E because they're not the same. All right, as x goes to 5, let's see, 1, 2, 3, 4, 5. As x goes to 5, if we approach from this side, or if we approach from this side, in both cases we're approaching this point which has a y coordinate of 1. And as x goes to infinity, we haven't talked about this yet, but as x goes to infinity, this is it's hitting a horizontal asymptote. Looks like the y coordinate is approaching 3.